So one other method for solving proportions is the cross-multiplying method that you learned as a seventh grader and probably as a sixth grader also. So cross-multiplying, if you have two ratios that are equal, you may have learned that if you cross-multiply, some people call this the butterfly method. The actual name is the means extremes property of equality. If you cross-multiply, 4 times x is going to equal 10 times 7. So 4x will equal 70, and when you divide by 4, here's my giant 1x, that's what I'm trying to get to. I get x is equal to the answer to 70 over 4. If you factor out a factor of 2, that would be 35 over 2. So x is equal to 17 and a half. 35 over 2 is a sufficient answer for this problem. But I want to show you how this is connected to fraction busting. If you had 10 over 4 equals x over 7 and we fraction bust it, then I could multiply by 4 on both sides. And I could multiply by 7 on both sides so that these become a 1 and those become a 1. That would leave me with 7 times 10 equals 4 times x. Notice that it's the exact same problem. So it turns out that cross-multiplying is kind of it's a shortcut that was invented by fraction busting. So when clearing those fractional denominators, you basically get the cross-multiplying method. But we need to know how to do both of them because the fraction busting method is going to apply to something bigger later. So then you would continue with this problem, divide by 4, you end up getting 70 over 4. So that would mean that 17 and a half equals x. Same problem. So if we were to apply that to our other problem, 10 is to 7 as x is to 1505. If I cross multiply, I get 7 times x is equal to 10 times 1505, which is 15,050. When I divide by 7, x is going to equal 2,150. Same answer, so 2,150, I think it was minutes. Anyway, that's cross multiplying.